morning, everyone.
Morning, sir.
So, how are you all guys today?
Yeah, very fine, Master. How are you?
Good. Okay, so today we'll be looking at chapter 5, direct currents. So the lesson objective for today is to discuss about the terminologies involved in the direct current and understand the equation and the constants involved. So this topic has a lot of constants there, and as we go along, then you will see. Okay, step 5, direct current, electric current. And electric current is said to exist when a group of line charges passes through a given cross-sectional area for a given time. If Q is the amount of charge passing through an area of time, interval T, and current is given by Q over T. So this Q is charge. What's the unit for charge? C. And time? Second. So remember, if the time is given in hours or minutes, you have to convert it to seconds. Otherwise, your answer will be wrong. And but the basic definition for this electric current will be a rate of flow of charge in a conductor. That's the basic definition. And you know a conductor, like it's a circle, it will have a cross-sectional area and the current flowing, like the area current and charge will be flowing. And the other thing, there's another equation in this topic. Q is equals to NE. Anyone knows what's this? Q is equal to this. You will use this to find the number of
Electrons.
So this Q will be here given. Electron, what's this? This is a constant value. And then we'll find your N. So always remember this. When they say to find the number of electrons, you have to use this, not a constant term. The charge will be given or the E will be given. E is the electron. Okay, this velocity, the symbol is V, small d. The cloth. The one you give to this one. Okay, drift velocity. So this is the conductor I was talking about earlier. It has the length, the area here, and the drift velocity is pointing this way, and the charge is also pointing this way, and it is v lambda of change of velocity, lambda time. So when the charge and the drift velocity is moving, it uses this velocity and changes time. So following the previous equation, what was the previous equation? I equals to?
Change in Q.
Change in time. Charge is equal to I. Then from there we'll get this equation, and we have the charge is given as charge density times charge times volume. So we have N E A lambda x over change in t. And we know that velocity is equals to
MS.
distance divided by time.
MS.
Yeah, it's ms. So we have NE lambda, A triangle dt change in time over change in time.
Just like 4 times.
So X is the length. And you have I is equals to Just always remember this, the derivation is not important. It's just the equation.
So that formula is within the formula sheet.
Anyone has the formula sheet?
Yeah, it's lost. Yeah.
It's there. The formula is there. Even the Q equals to I is given, so you have to rearrange it. Yeah, that's all.
You derive one formula.
You don't have to remember the division, just remember this. I equals to never, and A.
That's when finding the L.
Of the current of the conductor.
Current of the conduct. Traveling past the.
When the charge is also present. That's given in the note, so I'll be coming out. So we have I is equals to N A B D A.
Master, that B inside the thing is changes. B.
What?
I want inside the thing.
Master, do wonder one question.
B inside here. What's that? B.
Like one question.
That's the drift velocity.
VD.
Master, yes.
What?
Do one question.
Yeah, the next slide is the question.
And then
I is your current. Current in the conductor, which is in amps. M is your number of electrons. V, we know that's drift velocity and side velocity, but it's drift velocity. And your A is area.
Area.
So now, what is the area formula for this?
Surface is.
What's the area formula for conductor?
QT. Change in the thing, change in the.
No, the area.
pi square something.
Length times width. Length times width, area rectangle.
We have a conductor. Okay, we have a pipe, right?
R square.
What's the pipe?
Pipe.
What's the pipe shape?
Circle.
So, what's the area formula for circle?
Half
Pi
pi.
r square.
Half
Pi
r
square.
Pi r square.
Pi.
Pi square. So this will be your formula. That's why sometimes the length will be given or the radius will be given. So you have to use this to find your area, then use this to find your current.
So the question will always be like asking for the fiber.
No, sometimes it could be asking for that drift velocity. So I will be given. So you have to rearrange this. So if it's asking for velocity, so you'll have, the formula will be I is equals to NE A. Equals to your velocity. You have to find the area. Same ways. Sometimes it might say to find the length of the pipe. So you know the length is not given there, but you have to use this formula. Find the area, then use this formula to find your radius, like that. So the radius of the pipe. What's your E? The list of E.
Electron.
What's that? The electron constant. It's given as 1.6 times 10 to the power of negative 17. Yeah, it will be positive.
So confident.
Yes. You have copied this?
I finished.
Okay, the example. Do this. Okay, we'll do it together.
I never see goes to VD, that's the formula.
Huh? Never, I never.
Define velocity.
To find the velocity, I get to rearrange it. I was assuming. Okay, example. A 1.01 long silver, so long 1.01 would be the length.
That's X.
Yes. Silver wire has a diameter. See, the diameter is given now. Diameter is 1 millimeter. So 1 millimeter will be. But we have to convert it to that formula. What is the area formula? It is area is equal to pi r square. So we need the radius. So divide by 2. Calculate. Five. What is your calculator? Times 10 to the power of 2. Find the area then. 5 times
4
Mas tahu saya
direct.
7.8.
What?
5 direct.
Just like 4 times.
Transfers a 92 number charge. So we know that Q is 90 degrees. And in 75 minutes. So time is 75
minutes.
We have to change it to seconds. What's the time? So what will it be? Time 60 or divided by 75 times 60. 5 seconds. Yeah, so silver contains 5.8 times 10 to the power of 28 free electrons per cubic meter. So the E is also given there now. So it says calculate the current in the charge, the current in the wire. So what will be the current formula?
C is equal to and I is equal to net.
It says in the wire, not the conductor.
In the wire. I is equal to the wire.
What? Is the number of electron is
It's constant.
it's free electron. That's divided by time.
You have to use I equals to Q. Because the current is not given. Then your charge is 90
C.
and your time is 4500 seconds, 4500 seconds. What's the answer?
What is the value for current?
We are finding the current.
0.0
Amps.
What's that? You
0.0 amps. Now the second part, what is the drift velocity of the electron in the wire? Now we use the I is equals to N Make V the subject, yes. So V is equals to I over N E A. Now I we have calculated 0.02 into your N.
And
Oh, this was N.
into B.
Oh yes. 5.8 times 10 to the power of 28.
Times
So what's the thing? Electron.
1.6 times 10 to the power of negative 19.
And your
Area is
7.85.
times 10 to the power of negative 7.
So you first do all this in brackets. Then you do answer. You do 0.02 divided by answer.
Okay, bukan aku. 2.75 times 10 to the power of
Times 10 to the power.
Suka?
Oh yes.
It's
Oh, sombong master.
Master, when did you get I is equals to kilowatt T?
The first thing you learn, the rate of flow of charge through a conductor.
Iya. Mantap, man.
The next one is resistivity, and Ohm's law. So resistivity, that's the symbol. It's like P, but not exactly P.
Small p.
Like slant P. Resistance of a conductor depends on the length and the cross-sectional area of the conductor. So we have a conductor here and the length and the area. So the resistivity depends on both of them. Resistivity is a substance, is a constant value and is characteristics of a material. Therefore, current density J, remember this always, the amount of electric current flowing per unit cross-sectional area of a material. So we have this formula, J is equals to I over A, and we know that I is equals to nearby and E VBA divided by A. So A will cancel. We'll left with NEV. So that's your J. So if the question asks to find your current density, use this formula. Just don't write the area. What? If the question asks you to find the current density, just use this NEV, not the area. Area will be your current.
Master said it so.
No.
Master, what is this? Area will be your
Don't use the area here. If you have the area, then that will be your current in the never. But current, the current density is just now, NEV. Your J is your current density. What's the unit?
Joule.
It's a density. So you have current. The current we know is amps. Density will be your amps per meter square.
Density meters cubic. That's this, yeah. And with height. Oh.
M is your number of charge. E is the constant and this is the velocity. And for this one, this formula, R is equals to V over A. I over A.
It's L.
This is your, also the L over A. Oh yes, L. L over A, so this is your resistivity, resistance.
Master, that R is looking for the big R.
Resistance. So big R is your resistance.
Dari sisi itu maka.
Betul.
This is your length and this is your area. If it's says to find the relationship between R and A using a graph. What would you do?
Inverse.
So how do you do the graph?
Like this, curve like this. Gimana tuh?
What? Like this?
Ya.
What will be here?
That's the
Then we are the
Guys, done with this, okay?
Ibu mau pindah pindah.
Saya kasih gitu tuh yang
Menunggu baru baca Mantap kan?
Oke, terus yang belum Pak. Kapan nggak bisa? Terus yang belum Pak.
Okay, then next if it asks you to find the electric field, so earlier we have learned that J is equals to NE VG. Now you use these derivations here, then you'll come to E is equals to PJ. You want me to go over the derivation as well?
yes. So let's do electrical field.
Okay, we have V is equals to IR, but we know that V is equals to ED as well. So we will substitute.
So yes, D same as L because they are two.
No.
Oops. D is equals to ED. D same as L. L.
Oh yes. Okay, so V is equals to EL. L and D is same thing. It's the distance and the length. So we'll substitute here. V is equals to V. One side will be EL. One side will be IR. But we know that our R resistivity is equals to
D into L.
that's rho. Rho over L over A. And we have EL this side. And what's I?
So J is
Ini tadi application. So this one.
J.
Oh. Current density is equal to J is equals to IA. So we'll have I is equals to J A. So we'll substitute this here. So we'll have E L is equals to
J A.
J A
Rho.
L over A. So when you multiply, cancel A.
J rho L.
We'll have E L equals to okay, cancel L. And then E is equals to J rho. So E is your electrical field, P is your resistivity, and J is your current density. So you see, over here we have to find our current density. Then this question might ask, find your electric field. Then resistance, resistivity, and now Ohm's law is left. So what is Ohm's law?
V is equals to
V is equals to
So this one is resistivity.
No, so it's A, only.
which one?
What is resistivity?
Yes. But how will you define Ohm's law? This is as defined and write in mathematics. This is mathematical.
increasing more.
Is directly proportional to normal one.
We just did it.
Important
All is direct
increases.
proportional. So the velocity is directly proportional to current and cos R.
Resistance.